All right, looking at page 2 of the answer key, starting with number 4. You're pulling at an angle. The box is 70 kilograms, given in the problem. It's being pulled by a 400 Newton force, so that's our force of pull. That's the one here at an angle. It's at an angle of 30 degrees with the horizontal, so there's my 30 degrees. And the force of friction is 75 newtons. It says kinetic friction. That just means, friction, sliding friction. And we are taking a look in part A for the acceleration of the box, and in part B, we're looking for the normal force. First thing that I'm going to do is break up my force that's at an angle into its components, because I've already drawn all of my forces. Normal's up, friction's to the right trying to stop it from sliding, gravity's down, and my force of pull is up at an angle. So I know that I'm pulling some to the left, that's force of pull in the X, and some upward, which is force of pull in the Y. I'm just going to use my right triangle geometry, a little sine and cosine, to solve for those two pieces. So force of pull in the X is the adjacent side. That's why I'm using cosine. So force of pull in the X equals a cosine of the angle times the hypotenuse, or the force itself, which is given at 400 newtons in the problem. I do a little bit of algebra, and I find that I'm pulling 346.4 newtons to the left, going up and down. Force pull on the Y is the opposite side of this triangle. That means I'm going to use sine. So it's a sine of 30 times 400 newtons. Plug into my calculator, and I find I'm pulling 200 newtons straight up. Now I can do part A. Part A says, what is the acceleration of this thing? Well, I know it's going to be accelerating to the left, because that's the way I'm pulling it. So my force to the right is force of friction. Force to the left is my force of pull in the X direction. So friction minus force of pull in the X equals ma. Solving for A, I just divide by mass, and I can plug in my numbers. Friction was given at 75. The force of pull in the X, we found that earlier, 346.4 newtons, and the mass is 70 kilograms. Divide it all, and I get negative 3.88 meters per second squared for the acceleration. The negative just means that it's going to the left. B, what is the normal force? Well, my forces going up are the normal force, and the force of pull in the Y direction. That's why they are both positive. My force going down is the force of gravity. That's why it's negative. And all that's going to equal 0. The reason it's equal to 0 and not ma is it's not accelerating up and down. It's only accelerating left and right, or technically just to the left. So in the up and down direction, there's no acceleration, so it's still 0. That means my up stuff equals my down stuff. Doing a little bit of algebra, I can solve for the normal force. I add gravity to the other side and subtract force of pull in the Y. Plug in my numbers. Gravity is 70 times 9.8 meters per second squared. And force of pull in the Y we solved for earlier, 200 newtons. And I get 486 newtons for the normal force. Number 5. In this problem, we have a block. It's on a ramp. The angle of the ramp is 35 degrees. The mass of the block is 15 kilograms. And I'm pulling, given in the picture, at 150 newtons. It says the ramp is frictionless, so there's no friction at all on the ramp. We can pretend it's on wheels or ice or whatever you want, but no friction at all. Part A, what is the value for the component of the force of gravity that is acting against the tension? Well, what force of gravity is acting against the tension? Which one of these two components is going against the pull or the tension of the rope? And that would be this one, the force of gravity parallel. So that's what we're trying to find. That's my question mark for part A. What is it? Well, we have an equation for that. It's the sine of the angle times mg. It's on your equation sheet and on the board in class. Sine of 35 times the mass, which is 15, times 9.8 meters per second squared, is 84.3 newtons. Part B says, well, what's the acceleration of the block? Well, I know it's going to accelerate up the block, or the ramp. So my force to the right is my force of pull. My force to the left is force of gravity parallel. That's why I have force of pull positive minus gravity parallel, because it's to the left, equals ma. Solving for A, I divide by my mass. I can plug in my numbers. Force of pull is given at 150 newtons. Force of gravity parallel, we know, is 84.3 newtons. We just solved for it. And the mass is given in the problem at 15 kilograms. Plug that into your calculator, and you get an acceleration up the hill of 4.38 meters per second squared. Finally, part C says, what is the acceleration of the block if we add a 25 Newton frictional force? Now, where would that frictional force go? If the block is moving up the hill, the frictional force is trying to stop it from moving up the hill, so the frictional force is going to go down the hill. It's going to be to our left side. That's going to make our equation force of pull to the right, force of gravity parallel to the left, and friction to the left, all going to equal ma. Again, to solve for A, I divide by mass. That's why it's in the bottom, and the fraction here on the left side of my equation now. Plug in my numbers. Force of pull is still 150. Force gravity parallel is still 84.3, and the friction is 25. Divide by 15, and I get 2.71 meters per second squared for acceleration. It makes sense that if I add a friction force trying to slow it down, then my new acceleration should be smaller than it would be if there was no friction at all.